Welcome, morning everybody. I'm Claudio Giannotti, and I'm very glad to introduce you this fifth innovation talk of this edition. Innovation talks are open lectures on innovation, technology, sustainability, and the future of business in our society. Innovation talks are organized by the Department of Law, Economics, Politics and Modern Languages, and together with the master's degree in Management and Finance, and in collaboration with the LUMSA alumni. First of all, I want to thank Professor Filippo Giordano, who is the director of the program of the master's degree in Management and Finance, and all the innovation teams, in particular Alessandro Cavallo, Domenico Nesci, Andrea Geremicca, Livio Lamattina, and Claudia Proietti. So today we are going to have a special innovation talk about artificial intelligence and machine learning algorithms. I'm very happy that it will be held by Mino De Angelis, and so thank you to our lecturer, and I leave the floor to Domenico Nesci so he can introduce our lecturer for the lecture of today. Thanks a lot.
Thank you, Professor Giannotti. Hello, everybody. Very happy to be here with you, all of you, today for our new innovation talk. So these lectures are about innovation, and we talk a lot about innovation, and we talk a lot about software. We talk a lot about algorithms. We talk a lot about artificial intelligence. But are we sure that we know what we are talking about? I mean, have we ever seen, most of us, once in our life, a real software program? Have we ever worked on a specific algorithm? So to make things very real, we have today with us Mino De Angelis. Mino is a very experienced software technologist professional. He's a deep expert of all the new emerging, consolidating a new emerging software technologies. He's been an entrepreneur. He's currently consultant to big firms. So very happy to have you, Mino, today with us. We are very keen on knowing more about what artificial intelligence is in real and concrete terms. So thank you, Mino, for staying with us today, and looking forward to your lecture.
Thank you, Domenico. Thank you, everybody, and thank you for having me here. Thanks for inviting me, and let me say that it is a pleasure for me to speak to students who I hope they will find inspiration from the things I will talk about. Today, my goal is to give you a concrete idea about what artificial intelligence is in the real field, and how I can help us to improve the business processes. In 2 minutes, I try to frame the topic, and at the same time, I will tell you what relationship I have with AI. I want to start from the end. I want to see exactly what we are looking for. Suppose we are studying a phenomenon that we can describe with 3 attributes. Let me immediately use the jargon we use in machine learning world. This phenomenon could be the phenomenon of the failure of a machine. So we are in a lab, and we record the failure and not failure events of a stressed machine. That means that sometimes the machine breaks, sometimes doesn't. For example, you can imagine that we are measuring the temperature on one axis and the pressure on other axis. It is easy to understand that the red points are the not failure events, and the blue points are the failure events. Now, as you can see, it's not easy to find a correlation, a simple relation, because sometimes the points in the middle of the two subsets, the points are a little mixed. If I ask you, as a human, as a normal human being, to make a choice between the green line and the black line, usually every one of us, as normal human, we choose the black line. Why? Because usually we said that my experience also with the people is the black line is more reasonable. The black line makes sense. Yes, we know that choosing the black line, sometimes we have, let's say, an error. I mean, a point can be seen as blue and is really red, and the opposite. But we, as human, we are reasonable. So we need to choose the best line, best what means, best for us, more reasonable, you know. This kind of function is what the AI wants to address. The AI wants to imitate our power to understand, to learn from data, and to find the best solution to our problem. The problem is now that if we have only two features and one class, let me say that the blue and red, we can say define class in the machine learning jargon. So, or yes or not, or 0 or 1 is the same. So using the machine learning jargon, we can immediately say that we are looking a binary problem, a binary classification problem with the two attributes, temperature and pressure, one class. And this class can be one, yes or not. The problem is, what happens if we have 1 million of points and the attributes are, for example, 1,000? We now have only two attributes and few points. Imagine 1 million points and 1,000 of attributes. We can say that in this case, our ability as human absolutely is not enough to solve this kind of problem. Now, you can imagine that from the beginning of our history, I would like to repeat that I will use often the word human being, because the artificial intelligence, as I just said, is something that wants to imitate our intelligence, our way to solve problems that are not solved by a formula. We are in the world of not deterministic problems. This is the world where the artificial intelligence live. As you know, we as a human, started to use something to empower our physics strength. And for example, we built robots, the robots that amplify our physical strength. With artificial intelligence, we want to try to amplify our intellectual strength. Now, I want to come back to the history. And this story can see that starts with this man. He is Alan Turing, and we can say that he is the father of artificial intelligence. He, in the 1940, about 80 years ago, he started to study the problem of the artificial intelligence, and he designed a test to understand if how to decide, how to understand that if a machine can behave like a human, and this is called the Turing test. The Turing test is really simple, and the Turing test, as you see here, is based on the idea that if the person C cannot make a distinction between A and B, talking with them not by language, but with a written dialogue, if C cannot distinguish the A and B, that means that this intelligence that A has is an artificial intelligence. It is, now after 70 years, it seems to be something simple. It's not like this. It's not like this. Let me notice that he didn't use the voice because today and maybe in the future, it is really difficult to share concept using the language. It is a too difficult problem to address by now, and I guess also in the future. Now, the Turing, so the machine of Turing is the start of the idea of the artificial intelligence. And in the 50s, and exactly in 56, the scientists in a workshop in Dartmouth decided to call this topic artificial intelligence. As we will see in a few minutes, this choice doesn't help us to really understand what is the artificial intelligence. Now, this position, this idea, this invention created many problems in the second half of the last century, because there was a great expectation about this technique, but the computer power, the lack of data, you can think that we didn't have in those years the networks. The internet did not exist. So the only way to write a program, to run a program, was to have a mainframe in some place, and write programs and write down data and make the program running, in a data center somewhere alone, working alone. This was a real problem, and that's why the expectation was not, the results was not adequate to the expectation. So we had a long time in which the result was so poor that the expert called this period the AI winter. And to overcome this kind of problem, they used to invent something more simple that we called expert system. The expert system, let me show you. The most famous expert system was created by the digital. Digital was the most important computer company in those years. Actually doesn't exist anymore, and the digital used to build a expert system used to configure the server of digital. Consider that configuration of server means transformate from a qualitative description of server to a list of materials for the factory. This process is called the bill of materials for the mechanical factories, mechanical manufacturing. And digital in those years was able to save $40 million per year thanks to this rule-based configurer, this expert system. Let me say, I personally used to work on expert system in those years, as you can see by the color of my hair. And I use a software framework from HP in order to propose to customers, to companies, a solution based on expert system, but we have a very little success. Just to use an euphemism, I can say we didn't sell even one, because the expert system was too simple for the big problems that we wanted to solve. Anyway, everything began to change around the beginning of a new century in the year 2000, because the internet arrives. The computers begin to have computational capability. Algorithms that previously needed a mainframe begin to run on our personal computer. So since then, the acceleration had continued, and today we're considering the possibility to inserting an artificial intelligence module into business process. Using the technical resources that we have on a desk, I can create a component of artificial intelligence on the laptop we are talking from now. But there is another obstacle, maybe the last in our speech. The problem is the term artificial intelligence. This term is very, very good from a communicative point of view, but seems to be fascinating, but also obscure. People and companies don't understand what kind of help they can have from this kind of technology. Consider that the fiction and the media from those years. And also, actually, we are looking a movie, a famous movie, The Space Odyssey of 1968. I mean, the artificial intelligence, thanks to the choice of the terms, it becomes immediately something, about fiction, about imagination, about a future, about machine against that play against humans. It becomes immediately something to build an artificial man, artificial woman. Let's say all those stuff doesn't help, really doesn't help. It makes it difficult for company to understand what AI, how can be used productively. We have also in the commercial use, we have solution like, let's say, spam filters and let's say fraud detection, marketing analytics, recommendation system. All those things are really running by now. We have facial recognition. We have image classification. You can agree with me that image classification is not easy also for us as human. It's not immediate to distinguish from the little dog and the muffin here. So we are always dealing with things difficult to explain, difficult to understand. To understand how we can use these technologies, software technologies, I can propose a different perspective, a different point of view. The difference is here. If we change the A of artificial with A for augmented, as you can see here, you can see that you can find this page now on internet because it's a page from IBM. As you know, the IBM is absolutely the biggest computer company in the world by now, and IBM used to build solutions in a wide area of topics and also in artificial intelligence. But IBM is suggesting to us to change our point of view, our perspective. We don't want to substitute to make an artificial intelligence, also because exactly all of us imagine the intelligence, defining intelligence by example, but there does not exist an unique definition of intelligence. So we cannot create something artificial if we cannot define what is. It is different if we try to augment the intelligence, like the robots empower our physical power. It is the same. And this is the subject of the machine learning, really. The machine learning, what is? Or is the way the augmented intelligence can be built by software. So, leaving aside the matter of intelligence, of artificial, now we can try to we can begin to understand what we are talking about. We are talking about find in a data, as we do as human. We learn from data that receive from our senses, and all those signals, all those data are we elaborate those signals in our mind. This is exactly the same thing we want to do with the machine learning. You can see here, I'll show you another way to see the problem from the technical point of view, and it's data mining. I mean, in the same way we human learn from experience, we imagine that a software is able to learn thanks to the machine learning algorithm. It learns from data. What is data? Is a file. Is a file like the file you have on your computer by now. Is a table. Now we have time, and now we make the example we want to talk about. We are a bank, or we are a financial company. We are an insurance company. This example, it is quite realistic. It's not absurd. It's not invented, from scratch, and it's something real. We are a bank or insurance, and we have two problems. Let's say one old problem and a new problem. The old problem is the bad loans, the customer who do not pay the loan. This is a problem. We need to keep the rate of the bad customers as lower as we can. The new problem can be the happy problem, what we always call the happy problem. We have a fantastic growth of new customer. We have new customer. In this way, we have two problems, and we wanna solve this problem in some way. Suppose now that what happens if we have a growth of customer? The problem is if we use the same department with the same number of people, we have the problem that the response becomes low, and maybe the rate of error, to decide to give the customer to give or not the loan, the error rate is very probably increasing. So how can we solve this problem? How could we solve this problem as human? If you have time, all the time we need, we could decide to keep a group of experts, give them time, give them historical data, and maybe they could try to find some rule. Remember the first slide, the first one, some kind of rule that can help us to best classify the new customers. You can agree with me that it's not an easy task. It's not an easy task. Also because we don't have only two features to describe the new customer. Maybe we will add more. And here comes the AI system. The AI system, or as you know, now we can say not the artificial, but the augmented intelligence system, through the machine learning algorithms, can do better what we are unable to do really. I mean, can learn from data and help us to choose in a better way how to classify the new customers. Let's say another way to say that is the AI module can help us to predict in a better way if the customer will in the future pay or not the loan. You can see this definition from different point of view. Now we could go to the example, simple example, always simple. Yes. So we have, you can see, this is just a small piece of our history, file. This is the history that someone in the company gave us. As you can see, is a simple table with records and with a row and columns. I repeat that in the machine learning world, we call the columns feature. The last on the right is the class, and all the records we call instances. So we have a problem with many instances. All the instances are all the customer that we had in the past, and we have here the history of those customers. As you can see, the features are really self-explanatory. Current loan amount and term, years in current job. Let me say the purpose for the loan request. Let's say number of credit problems. All those are features. The description of the customer in this, let me say, hyperspace, because we are in a space not bidimensional, three-dimensional, but the space is defined by the number of all features. And finally, we have the class. We know the history, fully paid, it means, yes, they paid the loan, charge it off. It means they didn't pay the loan. So I can build a model applying an algorithm that should learn to understand how to predict for the new customer according to the behavior that is hidden in this data. I know there is something to say about. So another way to say is that the AI system should learn to predict the behavior of the new customer, learning from a data set of thousands of former customers. We can say that in this data set, there is probably hidden the pattern of the customer that will not pay and also will pay. We're looking at the past to forecast the future. How can we do that? We call the historical data the training data. The training data means that this is the data. We pre-process the data. As you can imagine, let me show you. As you can imagine, I cannot give to a software component all the data exactly as you see. I need to make some kind of transformation. As you can imagine, a software algorithm likes the number and not the strings, not the description. And this is, we call that pre-processing, you see. So we start from the data we have now. we make some kind of a pre-processing. It's only a matter of transformation. It's not nothing, conceptual. And finally, we have some kind of data, structured data with numbers, let's say. Another transformation, let's say, is a number transformed with values from 0 and 1, simple things from mathematical point of view. And finally, we have a machine learning algorithm that reading this data is able to create a model. A model is really a file that contains the model built reading the data of training. It is nothing so complex. Let me show you the algorithm that we have. We have thousands of algorithms, and the algorithm, for example, you can see here Bayesian is based on the Bayes theorem. The Bayes theorem is the theorem about the probability. And we can have the Bayesian tree, we can have, let's say, neural networks and rules. The algorithm is something able to imitate the way we as human are able to understand, to find a reasonable rule. Remember the first slide with few points, blue and red, and the black line. If you remember, we are looking exactly for the same, for something reasonable that can talk to us about the pattern, that the behavior that those data contains. Now, imagine we have the model and someone give us the file with the new customers. As you say, in every record, every instance, you can see the data, the feature for each new customer. And when we see loan status, this is in the future. On the training data, we had the past. Now we're looking forward in the future. So we don't know if how to predict. We need to predict what kind of customer will every customer in every row. What kind of customer will be? Will he pay in the future or will not? That's the classification problem, and the model can respond like this. Actually, if we had time, we could give this file to a model, and the response will be on the right. You see, AI classified. So the model is able to see to say, okay, the first customer seems to be someone that will pay, and so on. And you can see in yellow the no. I mean, the customer that probably they will not pay. Now, if we stop it here, the model seems to be a replacement for the humans. But the story doesn't end here, because we need to ask to the model something he knows. On the right, you see AI prediction rate. Every model is able to say us what is the prediction rate. Let me say, in a human language, I could say the model is able to say how much he believes the choice he made. Is a human language. In a mathematical language, is the probability that the model is able to calculate, to compute, to related with every classification he made. In this way, this prediction rate in the machine learning world has a range from 0.5 to 1. 0.5 means like to flip a coin, a casual result. 1, it means I am sure that yes is yes, I'm sure that no is no. At this moment, we as human come again in the game, and we need actually to choose a threshold. We could say, okay, I choose to believe to the model if the prediction rate is, for example, bigger than 0.75. So I say, this is the final classification. So the final classification is, I have all those new customers. I believe that the classification for new customer green is correct. I will examine as a human with the papers, you say, I will examine personally as department only the few record, the few customer that I think that should be evaluated from a human. Last real example, there is a Chinese hospital that actually used with the 24 queries with 24 attributes and with a training file of 300 million medical records, the model is able to discover with 19% of success diagnosis for more than 200 diseases. It's only a matter of number. Thank you for attention. I will leave.
So here we are. Thank you very much, Mino. We really dig into what, in real terms, artificial intelligence and specifically machine learning algorithms are. So this is the real stuff.
Yeah.
I mean, we many times we have the opportunity to read articles about this kind of technology, but very rarely we have the opportunity to dig into it. But I have a question. You made a couple of examples of in different industries. So one thing I would like to ask you is, is it the application of machine learning or deep learning algorithms the substantiate artificial intelligence are restricted to specific industries, or you have had the opportunity to see them applied to a number of different industries? So is it a kind of technology that can be used only for a limited number of problems that are specific to some industries, or these are more general, let's say?
The answer is absolutely general, And during time, every time I discover a new potential application in almost every industry. I used to, I used to examine. So the response is difficult for me to wonder where this technology is not is not useful. It's difficult for me. So really everywhere, in every kind of industry, in every kind of industry. Because, the idea is all the things we do as humans, because remember, this is the imitation game. The intelligence, the artificial intelligence is the imitation game. Imitation of what? Of we as a human, of our abilities, of our mind. And we can deal with any problem in the world, let's say.
Okay, very good. Thank you very much. I have actually another question. I'm particularly interested. Let's say nowadays in Europe we are talking about green transition and digital transition. So how do you see from an artificial intelligence perspective the connections between making a digital transition and making a sustainability transition, a green transition? So artificial intelligence can specifically be applied also to a number of problems that help humanity solve the sustainability problem. And do you have an example of this?
For example, in agriculture, there is a very, very interesting application. Let me explain. Starting from satellite images, you can understand what kind of pollution you have, how can avoid the pollution, also choosing the best plants to implant over, in any region. I have an example like this. I have an example of a data set where looking at what kind of plant is more able to live in a place, you can make the better choice. It's not a formula. It's a real application of machine learning, and so you classifying the right kind of plant to implant in a site, you can have a very strong, how do you say,
resistance.
And not only, you can have a better environment. You can build a better environment, choosing, what kind of plants you will plant there.
In a specific site.
In a specific site. And all those information, you can build a training set connecting the image from satellite and studies over ground directly. Is very, very interesting.
Very interesting. Thank you very much. Last question is a bit futuristic. You have been talking about the so-called narrow artificial intelligence.
Yeah.
So applying knowledge to solve specific problems, and you made an example.
Yeah.
What do you think about the general artificial intelligence concept? General artificial intelligence is our intelligence. So we're able, from our experience, to understand how to solve new problems. This is not part of the so-called narrow AI, but it's part of so-called broad AI or
Yes.
general AI.
Yeah.
So what do you think about it?
I really don't see now. I really don't see now something I can believe in. Maybe I'm also a technician, you know, I am a software engineer. Maybe I don't see the chance to afford this complexity. I only say the machine learning is not a matter of understand the reality, is only a matter to imitate a behavior. So this is my position.
So what you're saying is that we don't have to be afraid or scared that robots will take our place in the earth.
Absolutely not. I hope to be to have just gave a demonstration of that. The final word is always the word of the human. When I say you have to choose the threshold, the threshold to believe to the model, this is something human. The model is not intelligence. The model doesn't understand what is into the data. Only imitate the behavior of the data that the data have inside. Is only the imitation game. I remember that. Remember to you that to all that the movie, the name of the movie about the life of Alan Turing is The Imitation Game. Here we are dealing only with the imitation game. The word, the real wrong word, on my opinion, is intelligence. There is nothing intelligent here as a human. Maybe in next centuries, maybe.
Yeah. So thank you very much, Mino.
Thank
it
you.
has been very interesting for me, and I guess also for all our students. So we close it here. I don't know if we have Professor Giannotti closing the session. Yeah,
no.
I see him here.
Yeah, for me it's okay. Thanks a lot, Mino, for your talk.
Thank you,
Claudio. That's it. Thanks a lot for being with us, and see you at the next talk, everybody. Okay.
Bye.
Thank you, Domenico.
Thank you very much.
Grazie.
Goodbye, everybody.
Thank
Bye-bye.
you. Bye. Bye.